So we got x is 0 and y is -1/2, right? For our first point. Okay, did you put 0 in?
Yeah.
So what'd you get for y though? What'd you get for y?
I didn't use the same number you did, but
It's okay. I just want to know if did you let x equal 0 though?
I know.
No, you did. Okay, all right. And I'm gonna hit. Let's do let x equal 2. Okay. And so I got 8y plus 2 times 2 equals -4. I got 8y plus 4 equals -4. I subtract 4. I subtract 4. This cancels. I get 8y equals -8. I divide by 8. I divide by 8. I get y equals -1. So now I've got 2 and -1. Draw my graph. Okay, and I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. And I have 0 this way and -0.5. So I'm right there, right? And then I got 2. Okay, 1, 2. And I've got -1, and I'm right there. And so this graph's going to look, something like that. All right? Cool? Any others you guys want to see? Rachel? You look like you were thinking about it.
No.
No?
She's too tired.
I have a lot on my head right now.
You have a whole lot of what?
I have a lot on my head.
You have a life?
No. Yes, I do. But, yeah.
Well,
I just
more than
can't
most
even-
students have.
In our life, it's just a lot of stuff now.
Yeah, yeah.
Yeah. There's a lot of changes.
Quick question, so okay, I didn't get the assignment completely done, but the last part, the one that you said not to use the book, does it matter what numbers we put in? So we put it for X and
No,
Y?
I mean, the reality of it is this, okay? It's not that you don't use the book, it's that you don't follow the book's directions, right? And it tells you, I can't remember, it's 27 through 57 or whatever it said on there. It's a certain amount of numbers. It's on the, it's on the title of the assignment. It tells you. And it says, we're going to use the method we use in class. Plug and chug method says, pick a value of x, right? It doesn't say, pick 1 for x or pick 0 for x. So pick means you got your agency. You pick whatever the fetch you want. But at the end of the day, whether you pick, whether you pick, this number or this number or this number or this number, we can pick all these numbers. The graph's going to look like this. The line's going to look like this. If the line looked like that, we know we're way off, right? We did it wrong. So you got to look at the back of the book and check, does this look right? You got me? Okay, that's it.
Does that the what? Sorry.
You're good.
So when you say it has to look the same as it says as shows in the book for the answer, do we have to find a similar? What do you mean? Does it have to look like that, or just have to make sure it goes in that shape?
Well, here's the deal. If I graph the equation 2x plus 3y equals -6, I've graphed that line at least 100 times in my life, okay? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, okay? That line looks like this, period. It looks like that all day long, okay? That's the way that line looks. I mean, if I'm asked to graph that line, that's what the graph of that line looks like, okay? You get me? So I can pick a lot of different values of x, and that x could be here, or here, or here, or here. And if I connect the dots, it's going to look like this.
So it's supposed to look like that because both the x and the y are currently positives? Or not?
I think you need to do your homework. I'm not trying to be rough, but I think a lot of these questions are going to answer themselves for you as you start to do the homework. But if you haven't done the homework...
I'm just trying to make sure, I'm just trying to understand it. Like if I put in my numbers, it ends up being like the opposite of what the answer's supposed to be.
Can't be. Can't be. I want you to do something right now. Everybody, let's just do this, okay? I think you're onto something interesting, Kyle, that I'm willing to spend some time on. But I will say this, and I want you to recognize this. If you don't come prepared, don't have your homework done, and I spend a half hour teaching you as an individual because you aren't prepared today, then the other students in the class are like, hey, we got to move on. And so I do think Kyle's on something that's worthwhile for everybody to listen to. But I am saying there comes a point in time where I have to say, okay, we got to move on because you got to pay the price and be done. And if you'd have done that, then maybe you got this. But I still like what you're asking, and so I want to go in here. So I want everybody to do something with me right now, okay? I want you guys right now, look at me. I want you guys right now, I want you three right here No, U4 right here. I want you to come up with 2 points here, but I want you to let x equal 2, and I want you to let x equal 4. Okay, that's what you're going to do. This group right here, you're going to let x equal 2 and x equal 4. Hey, for that equation right there, solve it, okay? Okay, you ready for this? U3 right here, U3 right here. You got this?
Yep.
You're going to let x equal 0 and let x equal 3. Okay, you cool?
Mm-hmm.
And you're gonna graph this equation, all right? All right, U4 in this row, right here, okay?
If you want to.
Okay? You're gonna let x equal -2, and you're gonna let x equal -4, okay? Cool? This row right here. Okay, you guys right here, okay? U3, right here. You're gonna let x It's a powerful thing. You're gonna let x equal, you guys right here, you're gonna let x equal 1 and -1. And you guys, these 4 on the wall, you're gonna let x equal 2 and let x equal 5, okay? In fact, screw that, we're gonna go 1 and 5, okay? Cool? Okay, go. Now listen, hurry, go. Do this. Plug and shove, right now. Okay? Now, please listen to me. You 4 are going to get together in a group. Hey, you 3 are going to get together in a group. You 4 are going to get together in a group. You 3 are going to get together in a group. And you 4 are going to get together in a group. And you're going to look and you're going to confer and you're going to make sure that your graphs are the same. And you're going to come up here to this board and you're going to graph your fetching equation. Okay? Okay? So you just got to draw a graph. You got to do it. Okay?
You're just gonna plug
So I'm
into
gonna
that. You're solving for
take
y.
this to another level here, man. We need to hurry though. All right? We need to hurry. This wasn't part of the planned lecture today, but that's okay. But I want to. Okay. Okay, when you guys come up here and you there? When you come up here and you graph these equation, or sorry, the equation, I want you to write down the 2 dots that you got. I want you to write the coordinates. Okay, so we know what the x coordinate is. You're gonna have to tell me what the y coordinate is that you figured out that goes with it. Okay. Okay, this is one of those times in class where you can't take 10 minutes. So hurry and do this. You should have plugged and chugged these out. Get together in a group, confer, assign someone to go up there. Okay, get together and confer. Go, go, go.
I gotta ask you that.
Yeah, you just have to be careful. A lot of people forget the negative sign, so they get something completely opposite.
So, probably the question.
Yeah, if you don't mind me asking.
Yeah, go ahead.
But
The points here. You gotta write me your coordinates of your points. You guys have your coordinates. You've got your coordinates. You've got your coordinates. Okay. Yeah, you can just write it right next to the point. It's all good. Getting it figured out?
I accidentally did =6 and not -6.
Oh, there you go. Yeah. 2x plus 3y equals -6. There we go. Okay. Hurry, hurry. You guys are almost there. Good job. Thank you.
I know my lines off.
Yeah, but it's kind of, at least it's not like this.
Yeah, that is true. It's very true.
Or above the x-axis.
yeah,
Like,
because my y-intercept is x. That is the y-intercept, right? When x is 0?
yeah.
Okay. This is actually, okay. I want you to carry this line through. Just carry it through. Just carry it through the axis, everything. I want you to run it all the way through. Just go ahead and drive.
Yeah.
You can do it. You can come and do it. You don't want me to do it. Yeah, so is the rest of the world. Myself at the top of the list.
No, you're not on top of the
That's
list.
cool.
Well, I'm definitely not perfect at this.
Oh, really?
I've been doing it for years, and it's taking.
Where was the Purdue University at? They're like a
It's in
couple.
Indiana.
Oh, really? I was living in Indiana.
It was muggy.
I have to get the Great Lakes are there. Yeah. Like free money. I did that one time, like where there's just a shopping mall, like it's like all
Let's go. We gotta hurry, guys. We can do this. Okay, good. All right, yours is the only one I'm going to do because this is Kyle's question. I can't go through and check everybody's math on these, okay? Okay, in interest of time. You good? Whoa. It's all good, don't stress it. We're all good. Okay. Do these all look the same?
No, but yes.
No, but yes?
They all look the same.
Kyle, maybe you're the most important person to ask. Do all these graphs look the same?
Same direction wise, yes.
Okay, so here's the thing we said about, let's look at this right now. Look at this. Look at the distance from here to here versus here to here. Is that the same distance? I mean, look at this. From here to here, and then from here to here. That's a shorter line, isn't it?
Yeah.
So if I sat here and I drew all these graphs super fast, right? And I didn't make every line equidistant, could we be slightly off? Has anybody ever listened to Elder Uchtdorf talk about, you know, a plane in its trajectory and getting just a little bit off, and you can get miles off at the end of your destination? Yes or no?
Yes.
Now I want to show you something. This line looks like, look at me, look at my arm. This line looks like this. This line looks like this. This line looks like this. Okay? They're pretty freaking close. This line looks like this. They're all pretty freaking close. Off a little bit in trajectory this way or this way, but it's not going like this. It's not going like this. Okay, you getting me? It's not going like this, right? They're all the same freaking line. Okay, because you all graphed 2x plus 3y equals negative 6. Listen, folks, here's what I'm trying to share with you. I want you to grasp this concept. So done with this graph. Not you, that thing. Okay?
Do it.
Listen to me.
Savage.
Okay? I want to know on my line when x, look at this is the x-axis, this is 1, 2, 3, 4, 5. When x is 1, what's y? Negative 1, negative 2, negative 3, negative 4, negative 5. 1, 2, 3, 4, 5. So when x is 1, what's y? When x is 2, what's y? When, you get what I'm saying? Do you understand this? For every value of x, there's a corresponding value of y. How many points exist on this line? How many? We talked about it at the end of class. How many?
Forever.
Infinite. And if there's infinite points, every point is an ordered pair, right? An x-coordinate and a y-coordinate. So how many x-coordinates are there on this line? Infinite. And how many y-coordinates? Infinite. But every one of them is married in an ordered pair, eternal companionship, okay, to its value of y, right? Every x and every y are an eternal companionship in every individual line. And so as soon as I tell you to graph that line, that's it dictates it all. If I tell you to graph 3x plus 4y equals negative 12, going to be a different line. All different ordered pairs. But it doesn't matter what you pick. When you start to connect the dots, the line's going to start to form itself. You catching me? Does this make sense?
Yeah.
Okay. Now, it was a worthwhile discussion because I actually think that many of you don't get that concept sometimes. It's like there's a prescribed answer for what x is and what y is, and it's like, no. You pick your x, it'll chug out a value of y. That's why it's called plug and chug. You pick the x, it chugs out the y, whatever equation it is. And so look at you guys, and if we brought all these together and wrote them on top of each other, and here's what I want you to do right now. And this is where I want you to do this. I'm going to redo this one more time, but if you guys want to keep working on the math, I'd love. Okay, cool. Because I'm going to do something really fascinating right now. Watch this, okay? Now I'm going to draw a map, and I'm going to go as precise as I can for me. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, and 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7. All right, so that's about as perfect as I can get. There's still going to be some differences on this, but here's the deal, okay? I'm going to show you right now that I know that this line, I'm just telling you, this line in its perfect state, it looks like, those are the intercepts of that line, so it looks like, let's see if I can draw this as straight as possible. That line in its perfect state looks like that. That's what that line looks like, okay? Now, you guys, right now, read to me. What are my coordinates? My first pair. What did you get? You got 2.
-3 and 1/3.
Okay, so watch this. 1, 2, and negative 1, 2, 3,
And 1/3.
and about a third. Do you see that?
Mhm.
Puts me right there. Right? Catching the drift here? Give me the next one.
4 and -4 and 2/3.
1, 2, 3, 4, and negative what?
4 and 2/3.
1, 2, 3, 4, and I see 2/3. Put me about right in there, okay? Notice how this line kind of dips down a little bit. I mean, that can affect that, right? It's not graph paper. It's all perfect, okay? All right? You guys, what do you got? What'd you come up with?
0, -2.
There's that right there on it, okay?
And then 3, -4.
1, 2, 3, and negative 1, 2, 3, 4. Yeah, we're about right there. So it looks like we're definitely getting a consistency there. I think that dip in that axis definitely is we raise this axis a little bit, maybe, or whatever. I don't know. Okay, you guys, read this to me. What do you got?
-4 and
1, 2, 3, 4.
And 2/3.
And 2/3. Oh yeah, 2/3 would be up, and so 2/3 would put you about. So -4 and 2/3 would be about right there. Really interesting. All these dots are just slightly above my line. Yeah? What's your next point?
-2 and -2/3.
-2 and -1. What do you say?
2/3.
Oh, -2 and -1, 2, and about 2/3 of the way down. Be right there. And it's pretty much on my line. Okay? What'd you guys get?
We got 1 and then -2 and 2/3.
Okay, so you got 1 and -1, 2 and 2/3.
Yeah.
Right on my line. Perfect.
And then we got -1.
-1.
And then -1 and 1/3.
-1 and about a third puts me maybe right above that line. Are you seeing how this is all lining up, fetchers? What'd you guys get?
1 and -2.6 continuous.
1, 2, and 2/3, because you had the same exact point as somebody else because we had 1 somewhere else. I don't know, whatever. Oh, right next to you. Yeah. Okay. And then 5 and what?
5 and -5 and a third.
5 and -1, 2, 3, 4, 5 and a third puts me honestly right on the line, right about there. Look at that. Do you see what we're talking about now? So does it matter what X you pick?
No.
No.
Okay. Did that help anybody?
Yeah.
Besides Kyle? And I'm grateful it helped you, but did that help anybody else?
I think it solidified it more.
I like that. Anytime we can get solid, okay, I'm about that. Yeah.
Is there any rule that says you have to solve for X first, or can you solve for Y first and go from there? Like it'll result the same, will it not?
No, and we're gonna discover that today, but plug and chug is about plugging in a value of x and chugging out a value of y. There's different ways to graph. We said there's 3 methods. We're going to learn another method today and another method in a couple of days. And each method has its strengths. So you'll want to pick values of x and chug out values of y. And there's reason. Okay? So, okay. I think this right here, though, what we just did, that's kind of cool, isn't it? We took all your graphs and brought them together into one, and look at that. Look at this. If we were to draw a line through all those dots, it'd be, look at that. It's pretty much on top of the line I drew. And so all these are true. And people say, well, look at this one, Brother Rich. You see, really, it should have gone through here, okay? But I'll show you something really fascinating. Look at the distance between those two and the distance between that one, right? Really different right there. And if we think about this, if we have 1 and negative 2 and 2/3, that's about right there. But if we took this one and we changed this, and we went to 1, 2, 3, 4, 5, and we went to negative 1, 2, 3, 4, and 5 and 1/3 was more right in here, which would be maybe even more appropriate, we could literally go like that. Do you see that? And now the trajectory of that line has changed. You catching what I'm saying? Because you see what I'm talking about? The space between here and here and the space between there and there? So different. If we bump that up, okay, it changes the whole thing. And so I drew those really fast, and that's my point. Cool? Mm-hmm. Okay.
Groovy.
Good. All right. I want you to open up your notes to your basics page ever so quickly. We're going to talk about the concept of intercepts for a moment. Who likes American football in here?
Woo.
Say woo.
Woo.
Yeah. A few woos. A few louder than others. Okay, what's an interception in football? Somebody define for me, please. Interception in football?
Someone takes it away.
Okay, takes it away. That can happen multiple ways in football, not just with an interception. I want a little more specificity with interception.
Like if someone throws it and a different team catches it.
Okay, I like that. So if somebody throws the ball and the defense catches it, okay, that's an interception. Okay, so look at this. I hate to break your hearts, but the word interception is not a football term, okay? It's a term that deals with lines, okay? Everything you do in your life deals with lines. Look at the window. Look at that grid system right there, lines. And they intersect or intercept each other. Look at these boards. Look at this chair rail right here. All made with lines. And those lines are important because, like these boards, if we didn't line them up, one board would be slightly lower than the other, or they'd be angled like this. Lines are critical in construction, architecture, our day-to-day living, and in sports. Lines and angles are huge in sports. If you're a snowboarder or a skier, okay, and you're looking down that mountain, you pick your line. You pick what line you're going to ride down and go. You don't pick a line, you're going to be kind of rando and all over the place. Your ride might be a little more bumpy or not as fun or whatever. You actually, in extreme skiing, they have competitions where someone will go up to the top of the mountain and they'll ski down it or board down it, do tricks, do all kinds of stuff, and they'll get scored on their ride, okay? And the next person will do it. Well, when they're at the top there, they pick a line. They pick a line of where they're going to go and what their line of descent, and that line helps them get the most points because their line might launch them off one cliff and then another cliff. They can do a backflip or whatever, okay? Same kind of a concept. All of sports. Who's played soccer in here? Raise your hand if you're a soccer player. Basketball. Raise your hand if you ever played basketball, okay? Good soccer players make good basketball players. I'll tell you why. Because they understand the lines and the angles at which you pass things to get to the person before they get there, okay? So you're playing basketball on a basketball court. I teach my daughter this all the fetching time, okay? So here's your basket right here, and here's your three-point range and all this kind of stuff. And so we got, and I know it's kind of scattywampus, but if she drives down the center to go to the basket, okay, that's a line straight to the hoop, okay? But if she's coming in there, if a defender comes to her and cuts her off, and another defender comes and cuts her off, okay? What's so interesting is, as these defenders come and crowd in on her, all right, now they've left people, and that person become a line to which she can pass the ball. And it's just all seeing those angles and those lines. It's like you're teaching kids this, and it's like when you drive to the basket, don't just drive all H bent for fury that you're going to score, because if they crash on you, somebody's open. And so these lines, these angles are consistently, like you don't have to look all over the court. You don't have to stop and look around or stop and turn behind you, because this crap back here, it don't matter. You're not looking behind you. But you know, if you're coming right in here, you've got a line to here and a line to here and a line to here and a line to here, and it's always there. It's always there. So if you have your peripheral vision going and you drive down middle and you got your head up, you can see if people start to converge on me, if you can kick that ball out to one of those lines, right? Lines are part of everything we do. And so today we're going to learn about when two lines intersect each other, it's called an intercept at that point. The point of intersection is called the intercept. So if this is your x-axis, what's this one?
Y.
It's the y-axis. And I told you if you don't listen, I'll kick your axis. Remember that? Yeah? That's good. That's good. And, you know, this line that we're about to draw, it really doesn't matter. We're not even going to tell you what the equation of this line is. In fact, I'm going to make this line a little bit imperfect for a reason. Okay, so let's look up here. All right, so we're going to go, all right. So that doesn't really intersect at an exact point. This one does, all right. So this point right here, this is called the X-Intercept, okay? So again, if we have a quarterback, and the quarterback throws the ball to their wide receiver, and the corner jumps the route right at this point right here, steals the ball, okay? That's the point of interception, okay? Well, same kind of a concept here. Our line crosses the x-axis at the x-intercept. So the definition of an x-intercept is where our line crosses the x-axis. Okay? So everybody tell me, what's this point called right here then?
Y.
Oh yeah, it's going to be the y-intercept. And what's its definition?
Our line crosses y-axis?
Yeah, where our line crosses the y-axis. Okay? Now, overall, I want to ask you, last night's homework, okay? Hard or easy?
Easy.
It's pretty fetching easy. And on a one-day turnaround, we try to give you an easy assignment. We only have one one-day turnaround in this class. And we don't meet on Tuesdays and Thursdays, but this one time. And so that assignment was easy, okay? Tonight's assignment, I don't believe, will be that much more difficult when you have a 2-day turnaround on it, okay? So you got your x-intercept and your y-intercept. Now, one thing I want you to understand is that this y-intercept always is a specific ordered pair, as well as this x-intercept is always a specific ordered pair. Okay, let's think about this for just a minute. One of these values right here, no matter where your line goes. So listen, this line is specific, but I could have a line going here or here or here, right? And they can intercept at any given spot on the x or y axis. So no matter what my line is, one of these numbers is always what?
0.
0. Which one?
X.
X is 0. Okay, very good. 0. And this over here, which one is always 0?
The Y.
Y is always 0. Okay? Now we call this value of x A, and we call this one B. And I returned to something I asked you about 5 minutes ago. How many points are on a line?
Infinite.
Infinite. How many points do you need to make a line 2? But how many points exist on a line? Infinite. Which means there are infinite x and y coordinates, correct? Okay, so let's think about this for a minute. Answer this question. It's powerful. Is A an x coordinate? Yes or no?
Yes.
Yes! But we call it A to differentiate it from the infinite x values and x coordinates as the only one that crosses the x-axis. Clear? At that point. B. Is B a y coordinate? Yes or no?
Yes.
Yes, absolutely. It's a y coordinate. And so are all the other y coordinates on here. But we call it B to differentiate it from all the other y coordinates so we know where we crossed the y-axis. We good? Okay.
Do we put like an infinity sign like for the whole it's infinite kind of thing?
Not in this instance.
Oh, okay.
So that goes in your basics, okay? Write that down, make sure it's in your basics. As soon as you're done writing that down, go to your graphing page. And what I write on this left board, we're going to write on the graphing page, okay? So that goes under basics, right? Then you're going to come to the left board, and we're going to write some stuff in your graphing notes, okay? Okay. Method. What method? Okay, I want you to drop your pens and pencils for just a minute, please. Look up here. I'm going to go through this rapidly, okay? So, our next method of graphing is based on finding the intercepts of a line. So, instead of just randomly picking values of x, we're going to let x equal 0, solve for y, and then let y equal 0 and solve for x. Because you told me that 0 is a constant for the x-intercept, and 0 is a constant for the y-intercept, right? And so look up here. How many points do we need to graph a line?
2.
2. Okay. If we find both intercepts, how many points do we have?
2.
2. Okay. So finding intercepts can be a method of graphing. What's cool about the intercept method is it not only gives you a graph, but it reveals to you the intercepts of the line. And when you're taking a test, they'll ask many questions tonight in your homework, and you'll see similar ones on the test where they ask you, what are the intercepts? Okay. So I want you to open up your homework really quick. Hurry, 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 hurry. Okay.
Last night or for tonight?
Today. And I don't have my glasses with me today, so you're going to have to help me out a little bit.
So we're going to be your eyes.
And what is that page number? 2 what?
49.
2 what?
49.
249. Okay, 249. All right. All right. What do the directions say at part A for numbers 1, 2, 3, and 4? What does it say?
For exercises 1 to 4, find the coordinates of the y-intercept and the coordinates of the x-intercept.
And then they give you these graphs with little red lines on them. So all you're going to do, it'd be like me saying, okay, identify that point for the y-intercept, that point for the x-intercept, right? And you would write the coordinates down. If it doesn't go exactly through a hash mark, you're going to have to say, well, that's 1, 2, 3, 4, 5 and a third, or 5 and a fourth, or something, right? Okay, so you can do it. Okay, it's not an exact science, but most of these are going through. It looks like they're going through exact, points of, hash marks and stuff, and you're good to go. Okay, you guys good? You understand? Is this hard or easy?
Easy.
Okay. Now read the directions right below it for exercises 7 through 12.
Find A, the coordinates of the y-intercept, and B, the coordinates of the x-intercept. Do not graph.
Do not graph. So here's the next thing they do. Look at this. They give you an equation like 2x plus 3y equals -6, and they tell you, find its x-intercept, find its y-intercept, but don't even bother graphing it. Just find the intercepts, okay? But notice on both of these, which intercept did they have you find first? Are you paying attention?
Yes.
Which one did they have you find first?
Why?
Y. And then x. Do you think on a multiple choice test that if the y-intercept was 0, 2, okay, this is the y-intercept, right? 0, 2, and the x-intercept was 3, 0, do you think on a test that they could put it like 0, 2, 3, 0, and another one 3, 0, 0, 2? Could they do that?
Yeah.
Which one would be right, top or bottom?
Top.
It's the top, because they asked for the y-intercept first in your homework tonight. And I want you to recognize that, because on the test they do this. They tell you what order to find the intercepts in, and these little bastages, they love to screw with your mind. You know what I'm saying? If you don't know what a bastage is, I don't either. It's not even a word, but it means something.
But it doesn't matter the order.
It doesn't really matter what that word means either. It doesn't matter what order it's in, but if they asked it to be in the y-intercept and the x-intercept order, and they give it to you both ways, and this is a multiple choice test, if you pick this one, you're getting it wrong. You get what I'm saying? Yeah. So it does matter. You get what I mean? Because they're asking you to give it in a certain order. You got to give it to them in that order, right? And that's the thing I'm warning you about before you take this next test. Give it to them the way they want it, okay? Same thing as you do your homework tonight. Give it to them in the order they want it. Okay, the next direction, it says, for each equation, find the intercepts, then, what does it say?
Use the intercepts to graph the equation.
Okay, so now they're going to have you find the intercepts, but then also graph the equation. All right, look up here, please. To find the x-intercept, we always set the opposite variable to x equal to 0. So we're going to set y equal to 0, and we're going to solve for x. You see, this is just like plug and chug, but now instead of picking things, we are setting y equal to 0, solving for x. Now, if we want to find the y-intercept, what are we going to set equal to 0?
X.
We're going to set x equal to 0 and solve for y. All right? So let's listen. We just did this one. We just did this one. 1, 2, 3, 4, 5. 5 times across this board, we did that equation. We're going to do it one more time right now. We're going to find the intercepts, okay? We're going to do this together. So step number 1, I want to find the x-intercept, right? So I'm going to say 2x plus 3y equals negative 6, but I'm going to let what equal 0? Which one? Y. Okay? And so I'm going to say this is 3, and I'm going to say this is 0. And I'm going to do that because, look up here, if I want the x-intercept, I'm looking for a and 0, so y is 0. Okay? And you can call that a if you really wanted to. You could do that. You say 2a plus 3 times 0 equals negative 6. But we're going to say 2x, this cancels out, equals negative 6. We're going to divide by 2, and we get x equals negative 3. And so what is my x-intercept? Everybody, 1, 2, 3?
Negative 3.
What?
Negative 3.
Negative 3?
0.
0. Yeah, you got to give me the whole ordered pair, okay? Now, step number 2, right? Because this is my, look at, this is my first point, and this is my second point. And I got to have 2 points. So here's my second point. I got to find the y-intercept. I'm going to take, what am I going to set equal to 0 now?
X.
That's right, because now I got 0 comma b. Agreed?
Yeah.
And so I'm going to say 2 times 0 plus 3y equals negative 6, which makes 3y, because that just cancels out, equals negative 6. We're going to divide by 3 and divide by 3, and we get y equals negative 2. So what is my y-intercept?
0, negative 2.
0, comma, negative 2. So on this third part of the assignment here, they're saying find the intercepts. The second part, they just want us to find the intercepts, but don't graph it. So we would just do this, and we'd label this, the x-intercept and the y-intercept. Understood? That's all we would do. But on the third part, they tell us to find that, but then, raise that.
Oh, I need to take a picture of that. Sorry.
You gotta take a picture of this?
Yeah.
Dude, hurry, bro. If anybody else wants a picture of that, do it right now. Here, let me finish this. Okay, go. You want a picture of that? Picture it up. Okay?
Uh-oh.
You guys okay today? Adrian, how you doing, man? Are you good or really good?
Very good. You and your ex-wife are great together.
The ex-wife?
Yeah.
Oh, you're killing me, Smalls. Yeah, Adrian and the ex-wife. He's played that fiddle. Okay. So here we go. Got there, we got this here. Okay. All right, so let's go ahead and plot these 2 dots. It says plot the dots and connect. So we're gonna take, you tell me what to do. Where am I going? Left or right, up or down?
Left.
1, 2, 3, and
Point.
that's it. It's 0. Okay? And then my next one, am I going left or right or up or down or what?
Down.
Down? Right there? And then we connect them. Does that look like the one that we graphed 50 million times at the beginning of class today? Yes or no?
Yes.
It's the same fetching line. It should look like it. Okay? But we graphed it using the intercept method. Okay? I need you to do something right now. I need you to graph 2 problems. Okay. 5x minus 10 equals 5y. I want you to graph 5x minus 10 equals 5y. Okay? Go ahead and do that one. using the intercept method. Are we clear? Do not do plug and chug. Do the intercept method right now with this one, okay? You cool? Alright. So 5 times 0 minus 10 equals 5y. That's gone. Negative 10 equals 5y. Divide by 5. And y equals what? Negative 2. And we have, what's our x value? 0, comma, negative 2. Now, is this your x or your y-intercept?
X.
Your X. No,
The
it's
one
your
with the
Y.
number is the y-intercept, right? So this is y-intercept. This is your y-intercept. Okay? Now we got to find the x-intercept. So what do we got to set to 0 this time? 5x minus 10 equals 5 times 0. So I don't care what order you do it in, but you better know what the fetch you're doing. Meaning that, hey, which one do I get? So we're going to add 10 to each side. We get 5x equals 10. We divide by 5. We get x equals 2.
Wow.
And so now we got 2 comma 0. And what's the intercept is that? It's your x-intercept, right? And then you go to graph it. Let's look up here, and we're going to go 0 and negative 2. Look at 0, negative 2. So right in here. Agreed? And we got 1, 2, and 0. Yes?
Yes.
So that's that line. Going through there. Cool?
Cool.
Okay, we good with this? Okay.
Gucci.
So 2 different lines can have the same intercept, but be a different line. Interesting. Okay. Did you do this one? We got to do this quick. Pay attention. Okay? Y minus 3x equals 0. Okay? Let's let y equal 0. Why? Because we want to find the x-intercept. We clear? I think one of the things that would be helpful to you when you do this, instead of just randomly picking a 0, say I'm going to find my x-intercept. So I let y equal 0. I want to find my y-intercept. Just label them so you know which intercept you're finding. Okay? 0 minus 3x equals 0. Well, thank you very much. That's gone. Negative 3x equals 0. Got to get x alone. Divide by negative 3. Divide by negative 3. And 0 divided by any number is 0. So x equals 0. And so my x or my x-intercept is what?
0, 0.
0, 0. Now I made a point to you earlier. Every order has an eternal companionship for that line. They're inextricably connected for life, forever, for eternity. So that means when x equals 0, y is always
0.
And when y equals 0, x is always
0.
So I still get students say, but I got to find the y-intercept, Brother Rich. You're like, are you dropping? Okay. What's the y-intercept?
0.
0, 0. Because if y is 0, x is 0. If x is 0, y is 0. But it's okay because I used to be you and I asked the same question and I demanded the same thing. So why I say students do this all the time. I was a student and I did the exact same thing. So it's okay. Go ahead, find it. So you say, all right, well then if I do this, I have to set x equal to 0. So I let x equal 0. So I have y minus 3 times 0 equals 0. This cancels and I get y equals 0. So, you know, a few extra steps to prove to yourself that, yep, 0, 0. So here's the deal. Do you have a line?
No.
How many points do you have right now?
1.
1. And 1 is a dot. And that's an equal sign. So this is a line, fetchers. So what do you got to do?
Plug in another point.
You got to revert to plug and chug. You got to pick a value for x. You got to say, let x equal whatever you want. I'm going to say 2. Okay? So then we take this and we say y minus 3 times 2 equals 0. You can pick 1, 4, 5, negative 1, whatever you want. Just don't pick 0. Because you already got that. You've done it twice. Let's not do it a third time. Okay? And we add 6 to each side, and we get y equals 6, and we have 2 comma 6. And so now we go 1, 2, 3, 4, 5, 6, 1, 2, 3, and we go 1, 2, and up 6, and we're like this, and there's my line, and I'm done. Okay? So now you understand, why did we learn plug and chug? Because plug and chug always works. And you say, well, why do we learn the intercept method? The plug and chug always works. Why do I have to learn the intercept method? Because the intercept method teaches you how to find intercepts. And finding intercepts is really important in math because those are the 0 values. And 0 values are really critical. If you look at this, okay, on this line, when we cross this threshold above here, we're in the profit zone with money. We go below here, we're in the negative zone. We're losing money. I mean, 0 points, interception between the y and x axis, they reveal a lot of data to you that's important, okay? All right, that ends graphing. We have one more thing to teach you. Okay, we did that little exercise. None of my classes did that exercise we did in the beginning. And I thought it was cool. So I'm cool with it, okay? All right, but I got to teach you one more concept, all right? I need you to jump really fast in your homework to problem number 41. Read 41 to me. Thank you. X equals negative 2? Okay. Am I right or am I right?
Yes, you're right.
Okay. I gotta erase this middle board. You guys cool?
Mhm.
Yep, okay, all right. All eyes up here. Listen. You got 5 minutes. No, you got 4 minutes. No, you got 3 minutes, whatever. Look up here. Can you concentrate for 3 to 4 minutes?
Yeah.
Then do it. Look up here. They're telling you to graph this. Now please understand, if you graph this right now, and you go, -1, -2, -3, and you go, okay, there's my graph. Okay? Well, let me share something with you very interesting, okay? How many variables are in this equation right here?
2.
2. How many variables in this equation right here?
2.
2. Okay? How many variables in this equation right here?
2.
How many variables in this one?
1.
Okay? When you have a 1 variable equation, ... you either have 1, a horizontal line, or 2, a vertical line. That means horizontal, perfectly flat, vertical, perfectly up and down, right? Look up here, please. But what you don't have right here, you don't have a single point. Remember, a single point is an ordered pair. And an ordered pair, for example, in this instance, would be -2, 0. We weren't asked to graph -2, 0, were we? That would be a single point. But when you have an equal sign, you have an equation. And in math, an equation in the graphing world is a line. And so if you've got an equal sign, you got an equation. And that means you either have a horizontal or vertical line when you only have 1 variable. All these others, okay, all these other ones, okay, they have all this slope to them, right? And so you see that has an angle to it. The other ones had angles to them. So I'm going to draw you a little chart. This all goes under basics, okay? So all that I just wrote up there, you got to put in basics. So you want to take a picture of it real quick, but I got to teach you one last thing. I'm going to draw a chart. We're going to get out of here, okay? But you got to see this chart. And then we'll go. And then I'll see you Friday. Do not miss Friday. I'll bust your butt. Okay?
Your axis, right?
Your axis, that's right. Okay. We got horizontal lines and we got vertical lines. And we're going to make a chart right here. And the first thing we're going to do is we're going to put up here an example. An example of a horizontal line would be like y equals 2. And over here we have like x equals -3. Okay? And then we're going to graph it. And you're going to have a graph right here, and a graph right here, and a graph right here, and a graph right here. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And then we're going to give you the equation. And the equation will be, y equals b, and over here it'll be x equals a. And then we're going to have slope, and our slope here is m equals 0, and m equals undefined. All right, so there's the whole chart with a few little things I left out that I want to add in here for emphasis. So if y equals 2, we're going 1, 2, and we have a horizontal line right there. There's 2 right there. Okay, and if x equals -3 right there, and we have one little line right there. Okay, and this is this, and this is this, and yabba dabba do. Okay, all right.
This goes in basics.
Yep, all this goes in basics. Drop your pens, drop your pencils. Please pay attention to me for just a minute, okay? I'm going to prove something to you that's powerful, and then we got to get out of here. Okay? If I only have 1 variable, it's either horizontal or vertical. If you memorize this, you know that a y statement is always a horizontal line, which is weird because, think about it, the horizontal axis is the x-axis, isn't it? So why is a horizontal line a y equals equation? Well, you can debate that all you want, but it just is what it is. But if you don't want to memorize this, I have a really fast way to help you figure this out. I'll show you here in just a minute, okay? If I asked you to graph y equals 2, you don't have to use plug and chug. You don't have to use intercept method. All you do is you go to y is 2, and it's either a vertical or a horizontal line. Well, if it's vertical, then it becomes the axis, doesn't it? Well, it's not going to be the axis. So just do this. Are we clear? So it's a horizontal line. Just plot the dot and don't make it the axis, and you're good to go. Same thing here. X equals -3, go to the x-axis, put it right here. If we make a horizontal line, we're on the axis. It's a vertical line. We got it? But here's something else that's fascinating about this. We're going to quickly graph this one. Look up here. X equals -2. We're going to go horizontal or vertical? Vertical. Very good. Okay, but now I want to show you something really interesting, and then we'll get out of here. Trust me. Look at this, okay? 1, 2, 3, and 4. I want you guys to tell me right now, what are the coordinates of this point? Coordinates of this point, right here.
-2.
-2. Give me this one. Hurry.
-2, 0.
0. This one right here.
-2.
This one right here.
-2.
What is x equal at every point?
-2.
And that's why the equation is x equals -2, because for every freaking point, x equals -2. And look over here. On this vertical one, right? If I had you identify this point and this point right here, let's just do this really fast. Okay, this is going to be 3, 2, right? And this one's going to be 0, 2. And this one's going to be -1, 2. And so, what did y equal in all these? 2. And that's why it's y equals 2. You got me?
Gotcha.
Okay. You guys have a good one. You have everything you need to do this assignment successfully. I will see you Friday. We will be teaching you about slope, and that's this bottom thing right here. So you don't need to worry about that until next time. Oh, did I lose?